Hello everyone, welcome to my YouTube channel. So today we are going to discuss about the nanotechnology definitions and few backgrounds and how exactly the nanotechnology came and existence, all those things we will discuss. So in the previous class we discussed about the brief history of nanotechnology, and in that we learned that in the previous class we learned that the nanotechnology is not a new technology. It's just a new terminology we have given, but the technology was existing since 400 BC. So we also discussed about purple of glaciers, we have discussed about Maya blue painting, we discussed about Damascus sword, okay, which was famous for its sharpness and hardness, and we discussed about the Lagrange's curve, which is still famous for its color change in the presence of refracted light, which is giving a green color, and when it is reflected, when the light is transmitted through the glass, we will be getting red in color. So, and we know that we have concluded that was because of the presence of the silver and gold or stannic oxide nanoparticles present on the walls of this particular, whatever the examples I have just given. So when the materials is reduced to the less than 100 or 200 nanometer, so usually it's every property changes. That was the conclusion, take-home message from the last or the previous class. In this class, we discuss about the different terminologies like nanotechnology, nanoscience, nanomaterials, and how exactly all these things started, all these things we'll see. So actually, as we discussed in the earlier previous class, the nanotechnology, the people started working at molecular and atomic level only after Jet Friedman's famous talk in 1959. So there is plenty room left at the bottom. So that was he was addressing at the atomic and molecular scale. You have to, the scientific community has to work at this particular level so that we can bring new applications, because science there is totally different. And that's when people start working at the micro level and then keep on going to the molecular level, and when they reach to the nano level, so it is 1 to 100 nanometer or 200 nanometer. It was coming around 1971 or 1974. So Nario Takeuchi, he is one of the Japanese scientists working in Tokyo Science University in 1974. He coined the first terminology, that nanotechnology. That means the materials which are falling under the range. Range has to be very specific. You cannot simply say it as a 10 to the power minus nanometer is nanotechnology. No. So nanomaterials means nanotechnology in the sense it's about the exploitation of the applications of nanomaterials. So for that we need to know what is nanoscience. There has to be a nanoscale level, that has to be 1 to 100 nanometer. Okay, so the term nanotechnology was first defined by Nario Takeuchi of the Tokyo University in 1974. So that is the definition. So I just purposely put like this: the activity in other body science. The science is not even understanding the natural laws, right? And at here, what is nanoscience? At nanoscales. So nanoscale in the sense here, we cannot just write a nanoscale here. We have to mention it has to be or 0 to 100 or even 200 nanometer. That has to be the range. So range is very important here. So most of the material which will get a lot of properties, excellent properties in 0 to 100 nanometer. Some of the materials will even exhibit a strange properties compatible even above 100, like around 50 or 180 or 190 nanometer. That's why I mentioned 200 nanometer. Okay. So we know that science is nothing but study of natural laws at nanoscale, whereas nanotechnology because of nanoscience. So whereas nanotechnology is nothing but what? It's application of the science, right? So the novel and the practical application of this scientific knowledge, that is nothing but nanoscience, to change the world we live. Okay, so this is what The definitions we can define according to Balzani in 2005, whatever he has given as a this thing. According to the CNR Rao, what we are having is a one of the renowned scientists in the field of nanotechnology in India, and Chidam in 2002, they defined the nanotechnology as exploitation of the materials, that means the materials which are at nanoscale within this particular range. Okay, exploitation of materials with structural features, because that is surface to value ratio and energy band gaps, all those things, all the different hardness, that this we discussed in the previous class, right? So the same thing. So those kind of structural features at the intermediate range between the atoms and the molecular scale. Because what is the atomic size of the atom? It comes under 10 to the power minus 11 or 12, right? Whereas in molecule, it is minus 8. So nano falls under nano minus 9. So we are calling it as a intermediate range between the atoms and the molecular scale. But the important prerequisite that at least one dimension is in the nanometer length scale. That means only any one of the dimension has to be in nanoscale. So then only we are going to call it as a nanotechnology. Okay, so that was according to Rao and Cheetham. It's simple. You have a material whose range is around 1 to 0 to 200 nanometer, and if you are using these materials, okay, you're exploiting these materials characters like surface features, maybe their hardness or their optical properties or electronic properties, all these things. That's why it is called as structural features, because structural features will give you the all optical, electrical and many other properties. Next we have nanotechnology is the engineering of functional systems at atomic or molecular scale. So this is one word definition which is common. Nanotechnology is very simple word. Nanotechnology is nothing but it's engineering of the functional systems. You have to engineer some functional system. That means a system which should have some functions. Okay, and that has to fall under in the scale between the atomic or molecular scale. Then only we are going to call it as a nanotechnology. So what is nanoscience? So the nanoscience, as we discussed, the prefix nano is a Greek word that is nothing but dwarf, or you can say it is a small or a very small. So 1 nanometer is nothing but equal to 1 millionth of meter. That means if imagine 1 meter, we know. So here just to convince you people, make you understand you people how small it is. Okay, so you take 1 meter. 1 meter we have seen it, right? So if you are reducing this 1 nanometer, 1 meter into around billions of times to the meter, that is 10 to the power minus 9 zeros, then you are going to get the nanometer. As simple as that. That means in 1 meter, whatever you are having, that you will be getting billions of it. Okay. So about a width of 6 carbon atom, if you are comparing with the carbon atoms or atoms, you can say nano range falls around 6 carbon atoms, okay, or 10 water molecules. You can see the carbon, what you write in chemistry, 6 carbon atoms, like hexa, that can be the nano material. So in that particular thing, you can just imagine the hexane or other particular the scale structures are there. No? In that structure, even hydrogen molecules are there. If I'm talking about only carbon, if 6 carbons are combined, you can get 1 nanomaterial. That will be that's so small size. Imagine we are talking about atomic level, and when you are talking about atomic level, it is not a joke, because we know that the first atomic bomb, which was designed, okay, that was also from the atom. So we know that fission and fusion, because of these things only, it will explode the amount of energy from one particular atom, that is what uranium, right? So if you are able to remove the energy from an atom, you can produce a huge bomb out of it, atomic bomb out of it. That means huge amount of energy can be produced or released, right? So this is happening how? This is happening because at atomic scale science is totally different. Okay, so initially it was suggested And it was Einstein's students and his colleagues. They had got this idea in America, and most of their scientists they had stuck in Germany. And Germany, you know that Hitler was ruling in 1930s and 1920s. So he had one kind of rule that he had. What do you say? He had gathered almost all the scientists, and he never let them. He never allowed them to leave the country. So he made sure that they will be preparing some chemical weapons for him, those kind of stuff. And that was the era. So Einstein thought even if this guy got this particular idea, even his colleagues, the person who got this, the colleagues and their friends, they were also stuck in Germany. So even they would have got this idea. What if they come up with this particular atomic bomb or a nuclear bomb before the America? So it will be the destruction of the whole humanity, because Hitler was is not a good guy, because that was the reason. So Einstein wrote a letter to the White House by stating that they can have this particular kind of a weapon, so we need to make sure that we should have one in order to save whole world or America. So that was his letter. So but these people, America started working on it, and they spent around $2.5 billion. Okay, and they made finally one atomic bomb. But by then the war was over. Hitler was not there, and war was over. Germany was surrendered. Okay, so when this happened, but there was a conflict between Japan and America. They just wanted to try, and when they tried, the results. Hiroshima and Nagasaki, maybe August 6th or 8th or 9th, I don't know exactly, maybe 8th or 9th, 10th. So both Hiroshima and Nagasaki, they lost heavy lives. A lot of lives, a lot of civilians got killed. Okay, a lot of civilians are still suffering because this particular uranium, that whatever that has been toxic and was released, it entered into the genetic material. And when it started producing, even it came to a lot of, still a lot of people suffer because of this act, what America did. So Einstein says in one of the radio recording that he says that the worst thing I did in my life is to write a letter to the White House. So their intention was to save the humanity, save the world, but somehow world conflicts are not to be discussed, we need to discuss in this particular classes and all, but things go wrong, and that's one of the worst thing that happened to humanity, and that's what all these things are very delicate. This example I gave you, this story I explained you, because I just wanted you to understand how important these atoms are, and also for all these things, both Hiroshima and Nagasaki, whatever they use this atomic bomb for uranium nuclear bomb, how much amount of energy they have, amount of uranium they have taken? Any idea? Okay, it was not even 1 gram. Okay, can you imagine? So in which equation you can just fit this particular into E equal to mc square. E is nothing but energy, m is nothing but mass, and c you are having the speed of light to the sphere. So here the mass is very just almost, you can consider it as a 0.6 gram or something like that. You see how much amount of energy you are getting. So it's like a practically Einstein proved his E is equal to mc square. Not the sign. This phenomena proved that E is equal to mc square was so real. Okay, so human hair is that's what I'm telling. So at atomic level, if you're talking about, and at nanoscale, you're talking about, science is totally different there. That's why we need some new terminologies. The physics, what we aimed at studying at micro level and the macro level, we call it as just a physics or old physics nowadays. The new physics at nanoscience and atomic scale is totally new physics, and that physics we are calling it as a quantum physics or quantum mechanics. Okay, in order to understand nanomaterials, you need to understand quantum. You need to have the knowledge of quantum mechanics. Without that, nanomaterials cannot be understood completely, because they exhibit strange properties which are available only at nanoscale. Or atomic scale. And you have one more example here. So 6 carbon atoms and collected together fall under nanoscale, or 10 water molecules come under nanoscale. Then a human hair is approximately 80,000 nanometer wide. So that's what I'm talking about the diameter. Okay, around 80,000 diameter it is. So you can see that. Okay, now imagine 80,000 to just 10 nanometer or 80 nanometer. Okay, it will be almost 10,000 less than that. Okay, so or almost thousands of 1,000 times lesser than that. Next, we are having atoms are smaller than the 1 nanometer. So nanotechnology. Nanotechnology is conceptualized by Richard Feynman in 1959 in his lecture. There's plenty of room at the bottom. That means he wanted the scientific community to work at atomic and molecular scale, so that the new technology, new science, new articles, or new emerging technologies might come into picture. So that's exactly what happened. So that's why the credit goes back to the Richard Feynman, who was conceptualized. He never called it as a nanotechnology, or you have to work in nanomaterials. Later in 1974 it was called by the Nario Taniguchi, but he was the one who asked the whole community to work at a molecular and atomic scale. So that nanotechnology was the result of his conception. So that's why the credit goes to the Richard Feynman, one of the greatest physicists we have ever witnessed in the 20th century. So study and manufacture of the devices of molecular dimensions in the range of nanomaterials. It's also a definition of nanotechnology. There are 4 definitions of nanotechnology given in this class. You can use any of them. Okay, all will tell you the same answer. Okay, the manufacturing technology of 21st century. This was coined by many scientists and physicists and as well as the chemists. They consider nanotechnology the technology of 21st century, and because when that science was almost becoming stagnant, when the applications of engineering always become stagnant, it's the nanotechnologies carrying these particular applications. And the Moore's law, what we discussed in the previous class, is also one of the example. Without nanotechnology, we should have lost the Moore's law by almost just before in 2000, before 20th century, 21st century only. Now it is still going, and we are having a diameter of 100 nanometer to 100 nanometer, and the band gap between one transistor to another transistor is around 2.5 and 5.3 nanometer. One of my friends was working in Intel. He had when we had a discussion with about these reducing the size and increasing applications, he had when I was talking about nanotechnology and its fascination, because my master in nanotechnology, and we happened to study in the same college, like master, we both had studied in the same college, so we used to have a conversation. And later on he joined in Intel, and he called me up and he was explaining the fascinating technology what they are using in Intel in order to produce the chips or whatever the Intel chips we are having for laptops and phones or whatever it is. Okay, so almost not only Intel, almost all the technology, all these companies, those who are into the chip production, they are going to the micro level, to the nano scale, and they have to shift. And this shift is happening only because of the nanotechnology. So that's why we can call the nanotechnology as the manufacturing technology of 21st century. So nanotechnology, in 1970s, IBM in the US used a technique called electron beam lithography. That is the first technique used to create nanostructures artificially. Okay, we knew that 400 base of nanometals were there, they had prepared, but they didn't know that those are nanomaterials because of the nanometals were getting different properties, but they knew how it works. So that's how it is. So in 1970s, it's IBM, it's who discovered or who developed a technique called electron beam lithography, or used the technique, this electron beam lithography, to create the structures of size ranging from 40 to 70 nanometer. So they named it as a nanostructure. I mean, it came under nanostructure. So later in 1974, when they have called the term, so usually it was called as ultra fine particles. So now we are considering it as nanostructures of 40 to 70 nanometer. So conventional industrial manufacturing processes are based on the top-down technologies, That is nothing but usually what we are conventionally we are using top-down technologies to produce nanomaterials is like you take a bulk material, crush this until you get the nanoparticles. So that is what, that is where you get the top-down approach. Whereas bottom-up approach is nothing but from the atoms to the clusters to the molecules to the nanoparticles. That's how it is. So novel techniques. Novel techniques, that means old techniques usually you use the bottom up approach, whereas novel techniques or new techniques they are based on the bottom up approach, just like the cells. That was about the brief introduction about nanotechnology and this thing, and along with that I will just the background I will give you in the next class because it's also very important. It takes maybe half an hour, so I cannot just simply continue here. Yes, background we can take in the next class. So today we have discussed about the nanotechnology, the terminology nanoscience, and how the nanotechnology is different from the normal technology, all these things. I hope you understood. Let's get back.